Welcome to Advanced Indexing Techniques, part of the NumPy Power User Series. In this video, we'll master complex indexing patterns to unlock the full potential of array manipulation. These techniques are essential for anyone looking to work efficiently with multidimensional data in NumPy. NumPy provides four main categories of indexing. First, basic indexing uses integers and slices to access array elements. Second, Boolean indexing filters arrays using conditional masks. Third, fancy indexing employs integer arrays for non-contiguous element selection. And fourth, advanced tricks combine broadcasting, ellipsis, and multiple techniques for powerful data manipulation. Boolean indexing is one of the most powerful features in NumPy. Here we create an array with values 10, 25, 30, 45, and 60. We then create a mask by checking which elements are greater than 30. When we apply this mask to the array using square brackets, it returns only the elements where the condition is true, giving us 45 and 60. Boolean arrays act as filters, selecting only elements where the condition evaluates to true. You can combine multiple conditions using logical operators. In this example, we have an array with values 5, 15, 25, 35, and 45. We want elements greater than 10 and less than 40. Notice we use the ampersand symbol for AND operations and parentheses around each condition. This is required syntax in NumPy. The result gives us 15, 25, and 35. You can also use the pipe symbol for OR operations and the tilde for NOT operations. Fancy indexing allows you to select arbitrary elements in any order using integer arrays. Here we have an array with values 10 through 50. We create an indices array containing 0, 2, and 4. When we pass this indices array into square brackets, NumPy returns the elements at those positions, 10, 30, and 50. This technique lets you extract specific elements without needing them to be contiguous or in order. Fancy indexing extends to multiple dimensions. We create a 3 by 3 array with values 1 through 9. We define a rows array with values 0 and 2, and a columns array with values 1 and 2. When we index with both arrays, NumPy pairs up the indices. Row 0 with column 1 gives us 2, and row 2 with column 2 gives us 9. The index arrays for each dimension select elements at matching positions across dimensions. Index arrays can broadcast together to create powerful selection patterns. We reshape a range of 20 numbers into a 4 by 5 array. Our rows array has shape 2 by 1, containing 0 and 2. Our columns array has shape 1 by 3, containing 1, 3, and 4. When these arrays broadcast together, they create a 2 by 3 output. Index arrays broadcast according to NumPy's standard broadcasting rules, allowing you to select rectangular blocks or create complex patterns from your data. The ellipsis, represented by 3 dots, is a shorthand for skipping any number of dimensions. Consider a 4-dimensional array with shape 3, 4, 5, 6. To select the first element along the first axis and the last element along the final axis, we could write zeros : -1 for all middle dimensions. But the ellipsis makes this cleaner. 0 ... -1. The ellipsis automatically expands to whatever number of colons are needed, making code more flexible and readable when working with high-dimensional arrays. The real power comes from combining different indexing methods. We create a 4 by 6 array using arrange and reshape. First, we create a Boolean mask by checking which rows have a first element greater than 5. Then we use this mask to select specific rows and simultaneously use fancy indexing with a list containing 1, 3, 5 to select specific columns. This combination of slicing, Boolean indexing, and fancy indexing enables sophisticated data extraction patterns in a single operation. Let's recap the essential concepts. Boolean masks filter arrays by conditions, letting you select data based on logical tests. Fancy indexing selects elements at arbitrary positions using integer arrays. Index arrays broadcast together for complex multidimensional selections. And most importantly, You can combine these techniques for power user workflows that handle real-world data manipulation tasks efficiently. Master these patterns, and you'll be able to extract and transform data from NumPy arrays with precision and speed.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.